Hi everyone. In this video, I am going to tell you about NOR gate. NOR gate is another type of universal gate. So I told you already what do you mean by universal gate in the last class. I have completed NAND gate also in the previous video. So universal gate is nothing but a gate which is used to design any type of other logic gates. Okay, so NAND gate and NOR gate are the universal gates. They can be used to design any other logic circuit. AND gate we can implement OR gate, and even NAND gate can be implemented with NOR gate, and NOR gate can be implemented with NAND gate. So any gate can be implemented using these universal gates. Now, what do you mean by NOR gate? By seeing the name, we can understand that it is OR plus NOT. Okay, N means NOT, OR means OR gate, A plus B operation. So NOR gate is a combination of OR gate plus NOT gate. Okay, one more important thing, in the beginning of this logic gates, I have discussed three gates: AND gate, OR gate, NOT gate, named as basic gates. Any logic circuit, any logic gate that needs a basic gate. Even if you see, NOR gate can be implemented by taking OR gate plus NOT gate. These two are also basic gates. Okay, so OR gate followed by NOT gate is nothing but your NOR gate. OR gate symbolic representation is like this. Let us consider two input OR gate. So this is the two input OR gate. Output of this OR gate is given to an inverter NOT gate. This is the symbol with two inputs A, B and one output Y. Okay, so the output of OR gate is A plus B, and here it is the complement of the input, so A plus B whole bar. This is the output of NOR gate. So the combined gate, which is a NOR gate, that is consisting of both OR gate and as well as NOT gate, can be represented like this. It is also similar to OR gate. So bubble is representing the inverter. This is nothing but your NOR gate, A, B, Y, A, B and Y, A plus B whole bar. Okay, this is the representation of a two input NOR gate, of a two input NOR gate. Coming to the truth table of NOR gate, A, B, A plus B and Y is equal to A plus B whole bar. R complement is nothing but NOR gate. So for two inputs, there are four combinations: 0, 0, 0, 1, 1, 0, 1, 1. Okay, we know OR operation very well. If any one of the inputs is 1, output is 1. So it is 0, except that remaining all are 1s, because 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. Okay, now if you take the complement of all these outputs, then it will give you NOR operation. See, this is OR operation and this is NOR operation. So 1 followed by triple zeros. This is nothing but your NOR gate. This is your NOR gate operation. Okay, what do you mean by that? If all the inputs are zeros, then output is 1. In remaining cases, output is equal to 0. Okay, NOR gate is nothing but if all the inputs are zeros, then output is 1. For remaining all cases, output is 0. Remaining all cases, output is 0. That is the meaning of truth table of the NOR gate. Okay, now let us see in other way of representing a NOR gate. So NOR gate can be implemented using AND gate by taking a bubbled AND gate. Bubbled AND gate. Bubbled AND gate is the another type of representation of the NOR gate. So bubbled AND gate is also equal to NOR gate. Let us see how it is working. Bubbled AND gate is nothing but bubbled. Let us consider two input bubbled AND gate. For the same AND operation, we are having bubbles at the input. Bubble is nothing but inverter. Okay, this is A, this is B, and this is output Y. Okay. Okay, we don't know the output expression for this one. Just based on the name, I am drawing the logic gate. See, let us elaborate this one. We have an inverter here for A input, and similarly we have an inverter here for B input. The output of these two given to AND gate and then output Y. See what is the output here? See, both are same. Here we have taken bubble as per the name, bubbled AND gate. Bubbled AND gate. So bubble is at the input of the AND gate. So here one input, here another input. So bubble is nothing but inverter. So just I have taken out the inverter from the bubbled AND gate, and this becomes A bar. This becomes A bar. When you pass this A bar and B bar at the input of this AND gate, output is nothing but product of these two. Okay, standard operation of the AND gate is nothing but product of the two inputs. So A bar into B bar. A bar into B bar, according to Boolean formulae, it is A plus B whole bar. It is A plus B whole bar. A plus B whole bar can also be written like A bar into B bar. A bar into B bar. So this is A plus B whole bar, which is nothing but two input NOR gate. Which is nothing but two input NOR gate. So NOR gate can also be implemented like bubbled AND gate. See, this is equal to, this implies NOR gate, two input NOR gate, bubble. Here it is 1, here it is 2. So A, B, and this one is Y. So this is equal to A plus B whole bar. This is also equal to A plus B whole bar. So bubbled AND gate is equal to the NOR gate. Now, how a NOR gate can be used to implement an inverter? Let us see that. So NOR gate as an inverter. NOR gate as an inverter. In the previous video, when I was discussing about NAND operation, NAND gate can also be designed as an inverter when combining all the inputs. Okay, consider here also in the same way for a NOR operation, we have to short circuit all the inputs, then it will act as an inverter. Okay, we will check whether it will work in that way or not. Okay, consider two input NOR gate. So what is the two input NOR gate? This is the two input NOR gate. Here we have one input, here we have another input A, B, and this is Y is equal to A plus B whole bar. Let us take the truth table as well. A, B and Y 0, 0, 0, 1, 1, 0, 1, 1. So 0, 0, 1, remaining all cases it is 0. Now see, NOR gate, when both the inputs are zeros, then output is equal to 1. When both the inputs are ones, output is equal to 0. So for 0 input, we are having output 1. For 1 input, we are having output is equal to 0. That means if you concentrate only on these two inputs, then it will give you a NOT gate. Okay, so that means just short circuit the two inputs. This one connect to the second input, take only one input at the output, that is equal to A bar. Simply here we are having A as input, here also we are having A as input. That means both A and B, for this first circuit, both A and B are A's. If you substitute here A plus A whole bar. A plus A is nothing but A bar. That is the inverter. Okay. That means by short circuiting the inputs of either NAND gate or NOR gate, it will simply be converted into an inverter. Okay. So short circuiting the inputs of NOR or NAND acts as inverter. Okay, this is about the implementation of inverter using NOR gate. Now let us see bubbled NOR gate. Bubbled NOR gate. Already we have seen bubbled AND gate. In the similar way, bubbled NOR gate is nothing but we have to take a NOR gate, two input NOR gate, okay, and take bubbles at the inputs. For how many inputs we are having, that many, A, B, and this is output Y. See, A, after going to the bubble, it is A bar, it is B bar, it is A bar, it is B bar. So A bar plus B bar whole bar. It is A bar plus B bar whole bar because it is NOR gate. Otherwise, you can also represent like this for our convenience. Just I am taking the bubbles as inverters. This is output Y. So A, B. Now check what is the output. It is A bar, it is B bar. So this is equal to A bar plus B bar whole bar. A bar plus B bar whole bar. What is the output? It is A bar, it is AB whole bar, simply it is AB. Simply it is AB. That means bubbled NOR gate is acting as AND gate. Bubbled NOR gate is acting as AND gate. A, B, and this is how Y is equal to AB. So bubbled NOR gate is acting as AND gate. Okay, this is about NOR operation, NOR structure, and truth table and different forms of the NOR gate. In the next video, I will explain about exclusive gates like XOR gate and XNOR gate. Thank you.